Hi, welcome to our next probability distributions video for level 3. This is our third video for normal distribution. We're going to chat about inverse normal. This is where you are given a probability and we need to work backwards to solve a problem and try and work out either the mean, standard deviation, or an x value. Now in this video we're going to just focus on two of these, but they're all done in a similar way. Example 1. In an Australian mathematics competition, the top 10% of students receive a high distinction. In 2017, the mean score was 52 and the standard deviation of 8. What score did you need to get to be awarded a high distinction? Now we're assuming that it is a normally distributed competition, which it generally and probably would be. We're going to colour in this region here. This is the x value, the score that we're trying to work out, and this represents the top 10%. Right, well, we need to know this region between the mean and our x value, because that's what the table's got. We know that there's 50% of the data between the mean and above. So if 10% is in the dark blue, there must be 40% left over in this light blue. Now we can go to our probability distribution tables and we can look up 40%. So we're trying to find the probability as close to 40% as we can find. This is the number I've found, 0.3997, and that is a z value of 1.28. So we know we are 1.28 standard deviations away from the mean. Now let's come to our z equal x minus mu divided by sigma formula for standard normal distribution. We can substitute in the values for z of 1.28, the mean of 52, and the standard deviation of 8. And we're going to rearrange this to work out our x value or our score. So to do that, we're going to multiply the 8 by the 1.28, and then we're going to take the minus 52 and pop it on the other side to make it a plus 52. So we need to go 1.28 times 8 plus 52 to give us an x value of 62.24. So any score that is above 62.24 is in the top 10% and will receive a high distinction. All right, let's do a second example. Same competition, maths competition. This time the bottom 20% of students received a participation certificate. So in 2018, the mean score was 52 and a participation certificate was awarded for a score of 40 or less. What was the standard deviation for this competition in 2018? So once again, we're going to assume it's normally distributed, and we're going to put our mean of 52 in the middle, and we're going to, this time we've been given the x value, so we're going to put 40 and colour in or shade in everything less than 40. This is the bottom 20%. Now again, we need to know that there's 50% of the data between the mean and less, so there must be 30% in this region, which is the light blue, because 30 and 20 add up to 50. Right, well again we go to our standard normal distribution tables, and again we're looking for 30%. So 30%, the closest I can find is 0.2995. So that gives us a z value of 0.84. Now before you write down 0.84, you must write down negative 0.84 because we are below the mean. When we deal with z's, we put in a negative value if we are below the mean. Now we can go to our standard normal distribution formula, z equal to x minus mu over sigma. Let's chuck in what we know. We know the z value is negative 0.84. We know our x value is 40, and we know our mean is 52. Now we're just going to rearrange this to find sigma, the standard deviation. So to do that, we're going to multiply both sides by sigma, so negative 0.84 times sigma equals, and we know 40 minus 52 is negative 12, and then we're going to divide everything by negative 0.84 to give us sigma is equal to negative 12 divided by negative 0.84. The two negatives cancel, giving us a standard deviation of 14.29, which I've rounded to 2 decimal places. Right, that's us for inverse normal. Thank you.